Hello. Before we get started, I have to show off my Christmas sweater here. So, at the back there, he's got his little tail plugged in, and oops. So, there you go. So, something to brighten your day today. That is what is down here. Okay, today, now that you know that little secret, today we are working on solving a variety of percent problems. So we're on 7.3. So we're going to be using just different strategies, seeing which one that we like the best to solve some different percent problems. So let's go ahead. There's no spark today and jump right in. So make sure you have a paper and a pencil and are doing these problems with me so that you can answer the questions on your tasks. So number 1 here says that Liz is collecting aluminum cans for her school fundraiser. And let me get a pen here. So far, she has collected 16 cans. Oh, we do not want to write with yellow. Can't see that. So far, she has collected 16 cans, and that 16 is 20% of the goal. So 16 is 20. So that's telling me 16 and 20 should be matched up. How many cans must she collect to reach her goal? So we're looking for the total. So this is the piece, which is 20%. How many total? So first it wants us to fill out this double number line. So if you want to, on your task, you can open up your task here and see if you can fill out that double number line and then come back and let's check it out. So if I notice on the top, it's counting by 20 groups of 20. So went from 0 to 20. So next would be 40. It's just like counting by twos with a 0, 60, 80, 100. So then on the top, every time she gets 16 cans, that is 20%. So 16 plus 16 is 32. So when she's collected 32 cans, that's 40%. This is kind of nice if you have a goal that you're trying to reach, and each time you do something, this could kind of help you see what you need to get to, how far along in your goal that you are. So 16 more is 48. 16 more, oh, that's one that it's too early for me to do in my head. So I'm going to add these up here, and there's nothing wrong with that. So that's 14 and 64. So when they're almost to their goal at 80%, Liz has collected 64 cans, and then 16 more is 80. So when they have made their goal of 100% of their cans, Liz has collected 80 cans. So I want you to try that another way. So see if you can set up the problem in a different way and see what answer you get. So another way that I like to use is the proportion strategy. So here I have my cans, here I have the total. So I know she's got 16 cans, and I'm looking for the total. And I know that 20% is always going to be over 100. So it told me that 16 is 20. So notice that these are lined up and my totals are lined up. 100% is how many cans. So then I can do 16 times 100 is 1,600. And I'm going to divide by 20. So it can't go into 1, it can't go into 16, but it can go into 160, 20, 40, 60, 80, 100, 120, 140, 160. So it can go in there 8 times, perfectly 160. So nothing left over, bringing down my 0. 20 goes into 0, 0 times. You still got to put that 0. Every time something goes down, something has to go up. So I can see they needed a total of 80 cans. So that's just another way that you can solve this same problem. So go ahead and complete task 1 and then come back when you are ready to do task 2. Hey, Jose is in the same class as Liz, and he is also collecting aluminum cans. He has collected 36 cans, which is 18%. So I know these go together. It is this. When we hear that word, it's saying they are the same. So 36 is 18. How many cans must Jose collect to reach his goal? So we're looking again for the total cans. And this time it wants us to use that equivalent ratio strategy. So go ahead and see if you can set up your equivalent ratios and then come back and check. So I know he has 36 cans, but I'm looking to see how many total cans he needs. And I know 36 is 18, so these are lined up, and 18% is always going to be over 100. Percent means per 100. So now I can times by 100 here. 36 times 100, 3,600, and divide by 18. So I want you to see if you can go ahead and finish that problem there. So 18 goes into, can't go into 3, but it goes into 36 2 times. So 2 times 18 is 36 perfectly. So then we're left with nothing. 18 goes into 0 times. You've still got to put those down. Every time something goes down, something has to go up. So 0 times 18 is 0. Left over is 0. Bring down that 0. 18 goes into 0 times. So he wants to collect 200 cans. And when we're looking at our proportional reasoning, 18 is smaller than 100. 36 is smaller than 200. 36 is bigger than 18. 200 is bigger than 100. So no matter which way we're going, up or down, it should follow the same pattern. Okay, I want you to try another strategy here. So let's set up our problem. So we know we have 36 cans, and we want the total cans. We have 18%, which is over 100. So I want you to think about, what do you maybe know about the numbers 18 and 36? So take a second and think about that and pause the video. So when I'm doing 18, if I add up another group of 18, that is 36. Or if I did 36 divided by 18, it goes in there 2 times. So to get from 18 to 36, we need to multiply by 2. We need to do the same thing on the denominator. So multiply 100 by 2 is 200. So either way, we can use these equivalent ratios, or we can use the proportion strategy. And as long as we set them up correctly with the percent over 100, we will get the same answer there. Hey, go ahead and see if you can complete task 2. Hey, when you're ready, let's do task 3. So in Big Bog in Maui, Hawaii, about 400 inches of rainfall during a normal year. So this is their total. It is the 7th wettest place in the world, judging by annual rainfall. If 364 inches of rain have fallen, so this is what has happened already, this is what we need. So this is our part, this is our total. So over here again, we can see here's the total. 400 is what they expect. 364 have gone so far. So we need to get up to here. We're here. We're expecting more rain. So we expect the rainfall to reach the usual yearly amount. We expect it to keep raining until it gets to 400 inches. What percent? So we're looking for the percent of the year's rainfall has already fallen. Use a proportion to find the solution. Okay, so I want you to see if you can set up the parts and the totals with your proportions here. So go ahead and pause the video and try that out. So we know we have this part has fallen, 364. We're expecting a total of 400. So our rainfall matches up here. And then it says what percent. So I'm looking for the percent. And remember, percent is always out of 100 per 100. So it's not a very good writing job I did here with my mouse. So here's 100. So I'm looking for this percent here. So we can do this a couple ways. I can think, how did I get from 100 to 400? And then do the same thing here. Or backwards, how did we get from 400 to 100? Do the same thing here. We can also multiply here, which is 36400, 2 zeros on the end. And we're dividing by 400. So I know it can't go into 3, and it can't go into 36, and it can't go into 4. So see how many times you think it can go into 3,640. So if you're thinking fours, just counting by fours, but adding 2 zeros. So 400, 800, 12, 16. So I'm looking for something close to 36. So 4, 8, 12, 16, 20, 24, 28, 32, 36 is 9 times. So 9 times 4 is 36 with 2 zeros. So now we're left with 40, and bring down my 0. And 400 goes into 400 one time. So the percent of rain that's already fallen for the year is 91%. So now I want you to think about a question. What percent is still going to fall? What percent is still expected to fall? We know 91% has fallen. We're expecting 100%, so 100 minus 91. We're expecting 9% to still fall. Let's really quick check our reasoning here. So 364 is a little bit smaller than 400. 91 is a little bit smaller than 100. 400 is 4 times bigger than 100. 364 is 4 times bigger than 91. So no matter which direction we go, across or up and down, our patterns should be followed here. Hey, go ahead and complete task 3 and then do your check for understanding and let me know if there is anything I can do to help you with these percentages.